Good morning, students. Welcome back to science class on the chapter electricity. In the previous class, we had discussed about what is electric circuit and what is electric current and how electrons move inside a wire. Okay, so electric circuit means first we have discussed electric circuit. So electric circuit means a continuous and closed path of an electric current is called electric circuit. Okay, see in while drawing the circuit diagrams we use some kind of system, some straight lines and symbols of electrical equipments. Okay, next we have discussed electric current. So what is electric current? Electric current is nothing but it is a rate of flow of electric charges. Okay, and we have formula to calculate that current. I is equals to Q by T. Okay, so we can define the rate of flow of electric charges or the amount of charges passes through a particular area in unit time. And we have discussed the SI unit of current is ampere. Okay, and to measure current in an electric circuit we use ammeter. Okay, so ammeter is the device which measures the current. Then see the actually the SI unit of current is that is coulomb per second. Instead of this coulomb per second we use ampere. Okay, so you may know, right? So 1 coulomb is equals to 1 coulomb is equals to 6 into 10 raised to the power 18 electrons. 18 electrons. Okay, 18 electrons. And already we know, right, what is 1 ampere. Okay, see 1 ampere means if 1 coulomb of charges passes through a particular area in 1 second, then we can say that 1 ampere current is present in that conductor. Okay, next sometimes in electrical for very small devices, at that time we use very small amount of current. So at that time we measure current in milliampere and sometimes microampere also. Okay. Also, we have discussed one problem related to current. So today, first we shall study the symbols of electrical equipments. Okay, so this is very important for 1 or 2 marks. Okay, yes, first one, electrical cell. You know, right? This is cell. Okay, so you want to use this picture while drawing electric circuit. So instead of this one, we use like this electric cell. Okay, so here this is positive terminal, and then this is negative terminal. Okay, so you don't put like this. This is positive, this is negative, this is wrong, and don't draw like this. Okay, so this is another symbol. Here one here. See, this is very small compared to this line. This line it should be very small compared to this one. Okay, then you will do like this. Sometimes this is also wrong. Don't give too much space. Okay, just draw like this. So this is the symbol of electric cell. Symbol of electric cell. Next, battery. Battery means what? It is more than one cell. So this is the symbol of battery. Okay, so here positive, negative, positive, negative, positive, negative. Here negative of this negative terminal is negative terminal of this cell is connected to positive terminal of this cell. Then negative terminal of this cell is connected to positive terminal of this cell. Okay, here total 3 cells. Total 3 cells. Okay, so battery means what? More than one cell. 2 or 3 or 4 like that. Okay, suppose if it is value of 2, then this is 2, then 2 volt. So totally we can say that 6 volt. Okay, so this is a symbol of battery. Next one, plug or switch. Okay, electric switch. See, if you draw like this is open switch. Okay, open switch. If you put one dot here, then we call this is closed switch. If the switch, see, which represents the button is turned off, and here the switch is closed, right? Which means the button is turned on. Okay, so this is the symbol of electric switch. Or sometimes we use this type symbol also. Okay, this is also a symbol of switch. See, now this is open switch and this is closed switch. Okay. Yes. Next, a wire joint. Wire joint means what? You are connecting more than one or more than two wires in one point, at a one point. Okay. See. This is the wire joint. Okay. Next, wire crossing. Wire crossing. See, this is one wire and this is another wire. Okay, you can't draw like this. If you draw like this, which means this wire and this one are connected here, which represents this. See, this line, both are connected here. If you draw like this, okay. See, now this diagram represents here. This is wire crossing without connection. See, if you draw like this, then which represents this wire and this wire are not connected. Okay, this wire and this wire are not connected. But if you draw like this, we can say that this wire and this wire both are connected here. Okay, so this is wire cross. Joint. Sorry, wire without crossing. Okay. Next one, electric. This is a symbol of electric. See, the bulb is, this is the symbol of electric bulb. Sorry, the picture of the electric bulb. But symbol of that electric bulb is, see, this is the symbol of electric bulb. This is a symbol of a small or tublet. All kind of bulbs will draw like this only. Okay. Next, move to a resistor. Resistor. This is the symbol of resistor. We'll discuss later. Okay, what is resistor and everything? This is the symbol of resistor. Resistor. Okay. See, while drawing, some of you will draw like this. See, this is wrong. Okay, you have to draw like this only. Next, variable resistor or rheostat. See, this is symbol of resistor. For example, say its value is 2 ohm. We measure resistance value in ohm. Okay, see, 2 ohm. Here you will get 2 ohm only from this resistor. Here you will get exact 2 ohm only. But if you draw like this, if you draw like this is variable resistance. Okay, variable resistor. Here you can change the value. Suppose say from this resistor you will get say 10 ohm. Okay, then from this resistor you can get 10 ohm, 9 ohm, 8 ohm, 8.5 ohm, 7 ohm, 3 ohm, 1 ohm. Okay, so this is a variable resistor. From variable resistor we can get different values. Okay, see, first we should get maximum. Say maximum from this resistor we will get say 120 ohm, maximum 120 ohm. Okay, so now here you can see, here from this resistor we will get 1 ohm to 120 ohm. Here you can adjust for any value: 2 ohm, 3 ohm, 10 ohm, 15 ohm, 20 ohm, 100 ohm, then 190 ohm, then at last 120 ohm. Okay, here you won't get 120 ohm because limit is 120, right? Okay, but here you get different ohms. So that's why we call this is a symbol of variable resistor. Variable resistor. Then we have one more variable resistor, which is we call it as rheostat. Okay. This is a symbol of rheostat. Both are same, rheostat and variable resistor. Next one is ammeter. Already you know, right? What is the use of ammeter? We use ammeter to measure the current in an electric circuit. Okay. So this is positive and this is negative. This is the symbol of ammeter. Here this device which measures the electric current in an electric circuit. Okay, here also two terminals, positive and negative. And we connect ammeter in series. Okay. Next, voltmeter. We'll discuss later. What is the use of voltmeter? Okay. This is a symbol of voltmeter. Positive, negative. We use voltmeter to measure the voltage. Here also two terminals. One is positive and another one is negative. Okay. And this is not in your syllabus. For your knowledge purpose, I am saying. See, this is the symbol of capacitor. Okay, this is the symbol of capacitor. Then transformer. So this is a symbol of transformer, DC. Okay, so these are the symbols we use. We have symbols, but we'll study in higher classes. Okay, so using these electrical symbols, we will draw different electric circuits. Okay, so next move to electrical potential difference or voltage. I think you have heard it many times. 1 voltage, 2 voltage, 3 voltage, 50 voltage, 100 voltage, 120 voltage, 250 voltage, like that. Okay. See, electric potential or voltage, both are same. So voltage is the another name of electrical potential difference. Okay. Before that, see this example. You know, we have two water tanks. So both are connected using one pipe. Okay. See, this is the water level in tank A and this is tank B. This is water level. So now I will ask, So now see here I have connected both A and B using pipe. Okay. So now do you think that this water enters from this tank to this tank? This is the water level. Okay. So we can say that the water it won't move from tank A to tank B. Why? Because there is no pressure difference here. Suppose I will put the water up to here. So now, yes, definitely now we can say that water will move from tank A to tank B. Why? Because see here, now at this end and this end, there is a difference is there. What is the difference? Water difference, right? Sorry, pressure difference, right? This at this point and this point. Okay, so pressure difference is there. So that's why water enters from A to B. Suppose if see earlier the water level is up to here, right? Water level up to here. So both here and here there is no pressure difference. So that's why that water it won't move from A to B. But when you create the difference, pressure difference between this and this end, then only water enters from one tank to another tank. Clear? Now, here already we have studied what electrons move inside the wire. Actually, what makes it charges to move? Yes. See here, what makes electrons to move inside the wire? You know, for example, I'll take wire. Now, see here. See now I am not getting any kind of power right in this wire, okay? Because here there is no movement of electrons. Why? Because I am not supplying any kind of power. Okay? So now tell me what makes charges to move or electrons to move? That is cell. Okay? That is cell. So when you connect one wire to the cell, then electrons move. Then what is the function of the cell here? Then what is the function of that cell? Okay, so here this cell creates the potential difference. Okay, this cell creates the potential difference between two ends. So here, see, when water enters from one A to another, when water enters from A to B, if there is a potential difference between this end and this end, then only water move. Otherwise, it won't move. So here also, same. In an electric circuit, electrons will move when if there is an electric potential difference between 2 points. For example, okay, see here, if there is a potential difference between this terminal and this terminal in a cell, okay, negative, positive. If there is a potential difference exists between this terminal, then only electrons move from the negative end to positive end. Suppose, see here, what is this negative terminal? Here, more number of electrons. Here, less number of electrons. Suppose now, see, just imagine, I will take 10 electrons here. 10 electrons at terminal negative terminal and 5 electrons at positive terminal. So now difference is right here and here. What is the difference? That is 5. Okay. See, then only electrons will move from negative terminal to positive terminal. Suppose if here also 10 electrons, here also 10 electrons, then there is no potential, there is no difference, right? Between negative terminal and positive terminal, then there is no movement of electrons. So in a wire, electrons will move. When electrons will move, if there is a potential difference between these two terminals, then only electrons will move from one terminal to another terminal. Okay. So this is electric potential. Then see, then what is the electric potential difference? See here. Now electrons will move from negative terminal to positive terminal. Okay. See, we can define electric potential difference. Now, see, electrons will move from here to here. So now that work is done by this cell. So now here cell is which is creating potential difference. Correct? So inside, inside that cell, chemical energy is converted into electrical energy. You study about how it converts the chemical into electric in your chemistry classes. Okay. Here, see now, what is the function of the cell? The function of this cell just which pushes the electrons. So electrons will move from this end to this end through this bulb. Okay, through this bulb, electrons will move from negative terminal to positive terminal. So here that cell which pushes the electrons, right? Which means here that cell will do the work. What is the work of the cell? Just it pushes the electrons. Okay. How much work it will do? How much work it will do just to bring the electrons from negative terminal to positive terminal? Okay. So what is the work done to required to move electrons from negative terminal to positive terminal? That is called electric potential difference. Okay. To bring charges or electrons from negative end to positive end. Okay. To bring here this cell, it should do work, right? Okay. So that is called electric potential difference. Okay. See, first thing, how electrons will move inside the wire. If there is a difference between these two terminals, then only electrons will move. Then what is the electric potential difference? So the work done required to move electrons from one negative terminal to positive terminal. Okay, so this is called electric potential difference or voltage. Okay, both potential difference and voltage both are same. Okay, so we can define electric potential difference. Okay, so here the electric potential difference between 2 points in an electric circuit. In an electric circuit carrying some current as the work done to move a unit charge from one point to another point. The meaning is very simple. See, this is take 2 points. This one and this is point A, this is point A. Point B, we have electron here. Just I want to move electron from point A to point B. So how much work required to move an electron from A to B? That is called electric potential difference. Okay. So how to define electric potential difference? So it is the work required to move electrons or electric charges from one point to another point. Okay. So we have formula to calculate the potential difference or voltage. Okay. See, we use capital B, which represents voltage or electric potential difference is equals to work done per unit charge. See, if you know the formula, then you can define electric potential difference. Okay, W represents here work done and Q represents electric charges. Okay, we know we measure work done in joules, then Q in coulombs. Okay, the SI unit of voltage is joules per coulomb. The SI unit of voltage is joules per coulomb. Instead of this joules per coulomb, we use V, that is voltage. Okay, instead of joules per coulomb, we use voltage. Say you have seen this kind of values: 1 voltage, 2 voltage, 10 voltage, 15 voltage, 150 voltage, or 250 voltage. Okay, so then what is the meaning of 1 volt? Correct. See, volt is the extent of voltage or potential difference. Then what is the meaning of 1 volt? What is the meaning of 1 volt? See, 1 volt means 1 joule of work is done. Okay, 1 joule of work is done to move a charge of 1 coulomb from one point to another point. We have 2 points A and this is B. Okay, See, if you do 1 joule of work to move 1 coulomb of charge from this point to this point, then we can say that that is 1 volt. Clear? What is the meaning of 1 volt? 1 volt means what? So, in an electric circuit, 1 joule of work is done. 1 joule of work is done to move 1 coulomb of charges from one point to another point. Here positive and negative. Okay. First negative. Here, if you move 1 coulomb of charges from negative to positive, okay, to move that 1 coulomb, say you will do you will do 1 joule of work. So then we can say that 1 volt is okay. So this is the meaning of 1 volt. So clear, right? What is electric potential difference? So electrical potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge. So voltage means what? Work done per charge. Okay. How much you will do? How much the work is required to move a unit charge? Okay, so this is the formula to calculate voltage or potential difference. That is V is equals to work done divided by Q. So joules per coulomb is the essence of potential difference or voltage. In the honor of that scientist name Alessandro Volta, okay, we use voltage as the SI unit of volts is the SI unit of voltage or potential difference. So clear, right? See this 1 ampere and 1 voltage, these are very important for 1 marks. They will ask define 1 volt or define 1 watt, 1 ampere, or they will ask what is the meaning of 1 ampere, or they will ask what is the meaning of voltage, 1 voltage, like that. Okay, yes, so now we will discuss one small problem. And say already I have told, right, this is symbol positive and negative. This is the symbol of voltmeter. Symbol of voltmeter. We use this device to measure the voltage or electric potential difference. Voltage or electric potential difference. Okay. See. How much work is done in moving charge of 2 coulomb across 2 points having a potential difference having a potential difference having a potential difference 12 volt. Okay. Yes. So here how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference V. So now we need work done, right? That is W. Okay, we can relate V work done, then the coulomb, writing the formula, that is V equal to W divided by Q, right? So we can relate VWQ by writing formula, that is voltage or potential difference equal to work done divided by coulomb. Okay. Now see here. So we need a W, right? Then what is the voltage? V is equals to 12. Then charge, that is Q is equals to 2 coulomb. Yes, we know the formula. V is equals to work done divided by electric charge, that is Q, and we need W. Bring Q this side. V into Q is equals to W, or we can write W is equals to V into Q. What is V value? V is 12 and Q is 2. So what is the answer? So work done is equals to 24 joules. Here 24 joules of work is done. 24 joules of work is done to move 2 coulomb of charges from one point to another point. So to take one more problem. Calculate the work done. Calculate the work done in moving a charge of 2 coulomb through a potential difference of potential difference of 5 volt. So here also we need work done, right? Yes. So V is equals to 12 volts, and Q is equals to 2 coulomb. We need work done. We know the formula. V is equals to work done divided by Q. So bring Q this side. That is V into Q equal to work done. Then so work done is equals to V into Q. V is 12 volt. Sorry. V is 5 volt. Okay. 5 volt. Yes. So 5 into 2. That is 10 joule. So here 10 joule of work is done to move 2 coulomb of charges. Okay. So I will stop here. Tomorrow I will continue the class. Thank you.